My name is Jon Gibbs, Jonathan Gibbs. I'm the managing director of Savion Aerospace. We're a clean tech company. We're doing autonomous zero emissions passenger aircraft. So we're really developing the aircraft and the business model together to try to overcome some of the challenges with the high cost of green energy production. We've pivoted a few times like most startups have. What we're currently focused on is developing what's called a discrete regenerative fuel cell. So this is a type of fuel cell that can both generate power from fuel or hydrogen typically with other fuels, and it can also create hydrogen if you give it power and water. And we're trying to do these discrete regenerative fuel cells that are going to be on the vehicle itself, so that when the vehicle is not in use for transport, it can actually be used to make hydrogen. So that's our key focus, and we're doing that all the way from the customer development to the vehicle platform itself, all the way down to the components. We've got people working on all of those, and I'm sort of the conductor, trying to make sure they all work together and trying to propagate things that we learn, i.e. what customers want and what components can do backwards and forwards to make sure we get to a point where we can converge on a solution that works for everyone. So the physics of discrete regenerative fuel cells and even unitized regenerative fuel cells has already been known. What's unique about us is we're doing this in a compact vehicle format, right? So before, these components would be in a hydrogen farm and you've got to do all kinds of permitting. You've got to find land. If you can do it on the vehicle also has a regulatory process that's strenuous, but if you do it once, you can put that vehicle anywhere that the regulatory process applies, which is, for aviation, it's pretty much the whole world, right? So our theory is that by getting this right in a compact sense, we will be able to really quickly deploy all of these energy solutions across a number of jurisdictions. So the major challenges with the energy transition are not necessarily physics-based. So we know the physics of electrolysis, and the challenge is really financial, right? So, and the theoretical efficiency of electrolysis, and this has also been talked about in the Future Fuel CRC papers, you get around $6 or $7 a kilogram of green hydrogen, and you really need to be around $1 kilogram per hydrogen to have it penetrate the market, and so an existing fossil fuel user can decarbonize, right? So the physics is settled, and the cost that you can achieve with that physics is too high. So the cost of the business model is where we're going to try to innovate to try to fix that. So on one hand, you can have a government subsidize, but the government can subsidize everything, and everyone in other countries may not have the money to do that. And if economic conditions change, the subsidies end, which is kind of what happened in the US, right? So what we're trying to do with this discrete regenerative fuel cell is use the vehicle's transport revenue, either from flights, maritime, etc., to subsidize the production cost of the green hydrogen down to $1 kilogram. So that vehicle has already been paid for by the transport revenue, and it's not in use. The person who owns that vehicle is incurring a cost to park, just like we pay to park, right? So if they can actually make a little bit of revenue below the normal cost of production, but some revenue, that would count for the depreciation and maintenance, that cost might actually end up being around $1 kilogram. And you can have vehicles that are not in use producing hydrogen with the same physics as everybody else, but at a cost that now you can displace fossil fuels in other industries like logistics, green steel, etc. Well, I like to always look at market share. Us Americans, we're good capitalists. So what is the market penetration of green tech, right? I think worldwide, electric cars is the best. It's around 18%. In this country and in most areas, sustainable aviation fuels around in single digits, so 4% now, maybe up to 10% if we're lucky. And 10 or 20% isn't great, right? You really need to be at 100% or something close to that. So the real world impact is we're going to increase the market penetration of these technologies across the world in places that are rich countries like Australia, and in places that are less rich, that don't have a government that can subsidize. So if there's no government that can subsidize, the only other way to do it is through the market in the business model itself. So we hope that by simply proving our components are compact enough to fit in a vehicle, and then proving a business model can work, that we'll be able to go from a 4 or 5% market penetration of sustainable aviation, into something around 40, 50, 60. And of course, we hope people copy and we get to 100. So the top priority is to get a working proof of concept of our regenerative fuel cell. So we're probably going to have one that's demonstrates the physics, but it's probably not going to be powerful enough to power an aerial vehicle. So we'll do that, and we'll also have a design for a larger one. So once people understand the physics and they see the design, we are hoping to come and do the resources to be able to do this at scale, demonstrate one at scale, which isn't too expensive. But really, in parallel to that, we also want to do the customer development and really get the funding models validated, right? So it's not just the technology, you've also got to have the customers. And when you have those two things, an investor can have confidence. So the point of all of this for us is to get to a point where we can deliver confidence to an investor to be able to get things moving and get things moving in efficient spend.